Alright, here we are. Back again with a little bit of algebra action. We're talking about the quadratic formula today. That is chapter 9.5, and we're going to tackle this right here. So let's get ready for that. Alright, so that is the axis of symmetry here. We have x equals negative b over 2a. You've already memorized that. It's your new favorite formula. Well, you're going to have a newer, even favoriter formula, and that goes like this. We're going to add something up here to the negative b. We're going to add a little square root, just like that. Okay, now this part right here, under the square root, b squared minus 4ac, that's called the discriminant. And we will talk about that a little bit later. So we had the axis of symmetry, and now we've added the square root of the discriminant. Okay, and from Mr. Renault, I learned a little tune to help you memorize that, and it goes to Pop Goes the Weasel. So that goes like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, now go ahead and sing along, loud and proud. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And one more time. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, sing that many times and memorize your new favorite formula right here. With a quadratic formula, any quadratic equation can be solved, whether it can be factored or not. We looked at some prime situations, and we can't factor those, but we can solve it if it equals 0. So you can use this. Now, we've looked at different ways of factoring. We've looked at the difference of squares. We've done the box method. We've looked at grouping, factoring by grouping. So this one, if all else fails, you can use this one. Now, when we're working on this assignment, I will require you to write down the quadratic formula on every problem, and you will write it again and write it again until it sticks. You must memorize this one. Okay, let's look at using this. Okay, we'll solve this. Okay, the way we've solved it before, we've looked at this and said, okay, I can use the box method and solve that x minus 2, x minus 10 equals 0. Okay, and then, so if x minus 2 equals 0, then x is 2. If x minus 10 equals 0, then x is 10. Okay, this is how we've done it so far. If we can use the box method, we can do this right here. Now I'll show you how the quadratic formula would work for this specific problem. And it works the same, and it gives us the same results. Okay, so we've got two solutions, sometimes called zeros or roots of this function. Okay, using the quadratic formula for the same equation, we do the same step here to get the trinomial equals 0. Now, this first part right here is a, this is b, and this is c. Okay, we've already gone over that. That's what we're going to use in the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, so negative b, 12 is negative, b is negative 12, so we're going to put that in here, and that negative becomes positive, plus or minus the square root of negative 12 squared minus 4 times a times 20 times c, and the whole thing over 2 times a, 2 times 1. Okay, so we're going to start underneath the square root, which is the discriminant. We're going to simplify this expression right here. That gives me 144 minus 80. Then over 2, work this out. 144 minus 80 is 64. Square root of 64 is 8. Now we have a situation, okay, we're solving for x. We need to either add 8 or subtract it. Okay, because both negative 8 squared gives me 64 and positive 8 squared gives me 64. That's why I have to do both of those. So I have to either add it, 12 plus 8 divided by 2, or I'm going to subtract it, 12 minus 8 divided by 2. So one solution here is 10. and that other solution is 2. As you can see, we got the same solution here. Now on this one, it seems like a little bit of overkill because you could have done the box method. But it always works, and when you can't do the box method, then you're going to have to do the quadratic formula. Alright, so we're going to run through this one. A is 3, B is 5, and C is negative 12. Plug those in, and it looks like this. B, negative 5, 5 squared, and then here's A is 3 and negative 12, and then A down here again. Simplify under the square root, add them together, okay, and then we get negative 5 plus minus square root of 169. Find the square root here. Now we have two situations. Either we're going to add 13, okay, in which case plus 13 divided by 6 gives me 1.3 repeating, or 1 1/3. Or you get negative 3 if we subtract 13. Alright, one more example. Looking at this, we have A is 10, B is negative 5, and C is negative 25. Okay, now negative B is going to be negative 5, so we have positive 5. And then negative 5 squared, and here we have A and C. Okay, simplify under the square root, add it together, and then find the square root of this. And sometimes we don't come out with a whole number. Okay, sometimes you're going to get a decimal, and we're going to have to estimate. Alright, in this case, the box method probably wouldn't have worked for you. So, plus or minus 32. So we do plus 32 divided by 20, gives us approximately 1.9. Or we do minus 32 divided by 20, gives us approximately 1.4. Okay, so that's how the quadratic formula works. Okay, now I talked earlier about the part under the square root. That's called the discriminant. The discriminant is b squared minus 4ac. And the discriminant can tell us whether there are any solutions, and if so, whether there are two or only one solution. Okay, remember, there can't be a square root of a negative number. So if this turns out negative, there are no solutions. If this is 0, then we're not adding anything to or subtracting anything from b, so then there's only one solution. If it's positive, then we're going to add that positive number and subtract the positive number. Okay, so here the discriminant is b squared minus 4ac. b is 2, 2 squared, a is 1, and c is 5. So work that out, and we get the discriminant is negative 16. That's a negative number. Can there be a square root of a negative number? No, there cannot. So there are no solutions. Okay, what that means for the graph is that it never crosses the x-axis. Okay, so there's no point where the graph crosses the x-axis, so there are no solutions. Remember, solutions are also zeros. Okay, let's look at this example right here. The discriminant, b squared minus 4ac, b squared minus 4ac, okay, simplify, is 0. Well, if it's 0, we're not adding or subtracting anything, so we get one solution. What that means is the graph is touching the x-axis. There is one x-intercept, and that's right where it touches. So one solution. And then finally this situation here, b squared minus 4ac, negative 7 minus squared minus 4 times 2 is 49 minus 16. This is positive. So a positive discriminant gives us two solutions. That means it crosses the x-axis twice. It has two x-intercepts. Alright, we're going to state the discriminant here and the number of solutions. Alright, put it into standard form, and then we can figure out the discriminant. Here we go. Simplify that expression. 25 minus 48, negative 23. It's negative, so how many solutions? No solutions. Alright, and that was all you needed to do for today. All the fun we're going to have today. So, remember, ladies and gentlemen, to like and subscribe, and I will see you another day.